Okay, so here's numbers 9 and 12. For number 9, first you have to find the value of c, which is 17 after you do Pythagorean theorem, and the work is right here. So then you take sine, cosine, tangent, and you get the ratios. Now sine of alpha, of theta, here's theta. Sine is opposite over hypotenuse, so 8 over 17. Cosine is adjacent over hypotenuse, so here's 15 over 17. And tangent of theta is opposite over adjacent, so 8 over 15, and then you just do the reciprocals. Just flip these numbers here, here, and here. Number 12, you have two triangles, and so same thing, you solve for the missing piece. In this case, it's one of the legs right here. Here's Pythagorean theorem, and then you get a squared is 189. Take the square root of that, and so square root of 9 is 3, and square root of 21 is just square root of 21. Sine of A is 6 over 15, which can be reduced to 2 over 5, because it's opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, so it's 3 radical 21 over 15, which reduces to this. And then tangent is opposite over adjacent, so it's 6 over 3 radical 21. So the 6 and 3 reduce, and you have to rationalize the denominator, and that's what this is right here. You multiply top and bottom by radical 21, and so you end up with 2 radical 21 over 21. And then you flip each of these to get these right here. So here are 5 halves, 5 over radical 21, you rationalize it and you get this. And what I did for cotangent, notice that before we rationalized, we had 6 over 3 radical 21. So this is the one I flipped, not this one. I flipped this one. So that's where 3 radical 21 over 6, which reduces by 3 here and here. So you're left with radical 21 over 2. The smaller triangle, notice all the ratios are the same after you reduce them. And that's one of the questions. Why? Explain why the function values are the same. Because the ratios are the same. If you look at 6 over 15 and 4 over 10, when you reduce those ratios, you get 2 over 5. So even though this is a smaller triangle, the ratio is the same. As the ratios here are the same as the ratios here. This is just a little bit smaller. So notice all the numbers are exactly the same after you reduce them. Okay, right here, and cosecant is this one, and then cotangent is this one right here. So for 15, they told you that secant theta was 4, and secant is r over, it's a reciprocal of cosine. So it's hypotenuse over adjacent. So that's why I put the 4 right here for hypotenuse, and for adjacent I put a 1, because 4 is 4 over 1. So we need to solve for A. And here's the Pythagorean theorem at work right here. So that leaves you A radical 15. So all we have to do now is fill in the ratio. So sine is the opposite over the hypotenuse. So radical 15 over 4. Cosine is adjacent over hypotenuse. And again, you could have said, well, the reciprocal of secant is cosine. So 4, reciprocal of 4 is a fourth. Same thing. Tangent is opposite over adjacent, so tangent of theta is radical 15 over 1, which is just radical 15. Cosecant, reciprocal of sine, so that's going to be 4 over radical 15, but we rationalize it. And so this is 4 radical 15 over 15. Okay, and these numbers are 15s. I know they're hard to read. So 4 radical 15 over 15, and then 1 over radical 15, which you rationalize. So it's radical 15 over 15. Okay, so for 18, they gave you cosecant theta is 17 over 4, which that allowed you to label a triangle. Cosecant is a reciprocal of sine. So here's, and sine is opposite over hypotenuse, so then cosecant is hypotenuse over opposite. So that's why you have the 17 here and the 4 right here. So we need the A. Here's the Pythagorean theorem to solve for A, all the steps. So there. So the sine of theta is opposite over hypotenuse. so it's 4 over 17. Or we could have taken the cosecant and just taken the reciprocal of it. Okay? Cosine is adjacent over hypotenuse, the square root of 273 over 17. And tangent is opposite over adjacent, so 4 over square root of 273. So we rationalize and we end up with 4 radical 273 over 273. Secant, it's 17 over square root of 273, but after you rationalize, it's 17 radical 273 over 273. Okay, and then for cotangent, you just take the reciprocal of tangent. So I have two options for tangent, this one or this one. Well, I'm going to flip this one because then I'm done in one step. So it's going to be square root of 273 over 4. So the next few problems, 22 to 30, it's basically just using the unit circle because they want the angles from 0 to 90 or 0 to pi over 2. So that's quadrant 1 on the unit circle. So for 22, cosine of 60 is the same thing as cosine of pi over 3, so that's going to be 1/2. Secant of 45, which is the same thing as secant of pi over 4, well, it's the reciprocal of cosine. Cosine is radical 2 over 2. So when you take radical 2 over 2 and flip it, oops, let me write it the other way better. Radical 2 over 2 in reciprocal would be this. So you rationalize it. So it's 2 radical 2 over 2. The 2's cancel, so you're left with radical 2. For cotangent, they give you the ratio as radical 3 over 3. I always take it back to its to the form right here. This number is the same as this number before it's rationalized. This is the rationalized number. This is not rationalized. So remember, cotangent is x over y, right? Reciprocal of tangent. X over y. So then I know that the coordinate for x is 1/2. The coordinate for y is radical 3 over 2. So 1/2 radical 3 over 2 would be 60 degrees, which is pi over 3. So for sine pi over 4, well, pi over 4 is 45 degrees. So the sine of 45 degrees, that's one of the answers, is radical 2 over 2. Tangent, theta is 1 over radical 3. Remember, tangent is y over x, so this means that the x-coordinate is radical 3 over 2, and the y-coordinate is 1/2. So radical 3 over 2, 1/2 would be the same as 30 degrees, which is pi over 6. Okay, for 32 through 36 is strictly calculator problems, so you just have to make sure you're in the right mode. So for 32, 34, you're in degree mode. And remember, they want 4 decimal places for the answers. This one, just remember to use the keys on your calculator, the minutes and the seconds. And then number 36, you're in radian mode because there's no degree symbol, so you're in radian mode. And then this is the reciprocal of cosine, so you would put in 1.54 cosine of that, and then reciprocal it, and you get that. And remember, these are not angles. These are all ratios. Ratios are not angles. For 73, you have a right triangle. They gave you one angle, and it's one of the special angles. So if you look at the instructions, it says find the exact values. So that means we're not using a calculator. So you have to find r and y. So I set up, because I have this angle and I'm looking for y, it's opposite over adjacent, so its tangent of 30 is y over 105. I multiplied by 105 on both sides, so you get y by itself equals 105 times tangent 30. Well, tangent 30 is radical 3 over 3. 3 goes into 105 35 times, and so that's the exact value. Okay? Because after this, you would have to use a calculator to get the approximate value, because radical 3 is an irrational number. For the other one, for the r, to solve for r, it's a hypotenuse, so I'm going to have to use cosine. So cosine is adjacent over hypotenuse. So here it is, 105 over r. And so when you solve for r, you get 105 divided by cosine 30, right here. Now cosine 30 is radical 3 over 2. And remember, when you divide by a fraction, you're multiplying by a reciprocal. It's reciprocal. So here's its reciprocal, and we're multiplying. I'm going to rationalize the denominator, so I'm multiplying top and bottom by radical 3. And so that gives me 210 radical 3 over 3. I can reduce this to 70, so 70 radical 3. For 75, you're missing x and y, and this time the acute angle is 60. So here you have sine of 60, so it's opposite over hypotenuse, so y over 16. Multiply by 16 and you get this line right here. Sine of 60, remember, is radical 3 over 2. When you multiply, you get 8 radical 3. For x, we're going to use cosine. So cosine of 60 is adjacent over hypotenuse, so x over 16. Multiply by 16 on both sides, so you get x equals 16 times cosine 60. And cosine of 60 is 1/2. So a half times 16 is 8. So 77, I drew a more simplified picture. Here is the ramp right here where the cars are traveling, and it tells you that the elevation on the tip of the ramp is 1,693.5 feet. So that's from sea level all the way to the tip of the ramp. Okay, so this is like the street level right here. So you have to find the vertical distance that this ramp travels. So and this is angles 35.4. So sine of 35.4 is opposite over hypotenuse. So that's what is set up right here. Take your calculator to multiply the 896.5 times sine of 35.4, and you get this number right here. Then they want to find out, for B, find the elevation of the lower end of the inclined plane. So they want to know how high it is from here to here. Okay, so while you know this distance, it was given to you, and you just figured out this distance from part A, so then all you have to do is subtract this minus this to get the y value, to get the elevation from the lower end of the inclined plane. So when you subtract the numbers, you get this. Now for part C, it tells you that the cars are going at 300 feet per minute, okay, and they want to know the vertical speed. You know, how long does it take for the cars to travel the vertical distance? Okay, it takes they go at 300 feet per minute going this way. What would that translate to in vertical speed? Okay, so distance equals rate times time, and so if I divide by rate, I get time equals distance divided by rate. So here's the distance they travel along the path. Here's the rate. So that gives me, it takes them, at that speed, it takes them almost 3 minutes to travel, right? So here's the time. So then to find the rate, the vertical rate right here, it's distance divided by time. Again, going back to this formula, but solving for r. So I divide both sides by t, and you get this. So the distance traveled, that's 519. That's the answer from part A, okay, because that's the vertical distance, divided by the time that it takes to get from here to here. That's almost 3 seconds, so I kept all the digits, okay? So you just divide, and you get 173.77 feet per minute. That's your rate. That's your vertical rate. Alright, so 79, you were given the figure with the triangle and the missing piece, so this is what you're solving for. So given this and this angle, and looking for this side means that you would use tangent, because tangent is opposite over adjacent. So this is the setup right here. Multiply by 100 on both sides, so you get W equals 100 tangent 58. Punch it into your calculator, and you get 160 feet. So for number 93, you fill in the table using your calculator. Make sure you're in degree mode, and you see the answers here. So after you fill in the table, you notice that sine is increasing, the values are increasing, cosine decreasing, and tangent increasing. And finally, for part C, you take the values here and put them as a ratio, and then put them into a calculator to get the answer. And this is what you get straight from the calculator, and this is from the ratios. And if you notice, they're pretty close. this one, this one, this one.